Good morning, everyone, or good afternoon, or good evening. Thanks for joining us for our final day of our three-part series of virtual open dev events. So welcome to Containers in Production if this is your first day here.
Awesome. Hi, I'm Allison Price, and Ashley Ferguson and I are going to be your MCs for today. So we're going to go through how to participate and then kick off today's discussions. Like Ashley said, this is our third virtual event, third virtual open dev event this series, and it's going to be on containers in production. And if you missed yesterday's discussions, the recording is on the website at openstack.org/opendev. Our next virtual event hosted by the OpenStack Foundation is the Open Infrastructure Summit. This will be October 19th through the 23rd, and it's a free virtual event. So I definitely want to encourage everyone here to register. We have the link here to register as well if you're interested in your organization sponsoring the summit. And the CFP may have closed last week, but if you're interested in a speaking opportunity, email us and we can discuss some options with you. And now Ashley will provide an overview on how to participate.
Thanks, Allison. All right, so I'm sure most of you have been to an open dev at least for one day by now, but if you haven't, we just wanted to give you a quick rundown of the tools that we're going to be using just to make this event as smooth as possible for you. So the first tool we're using is Zoom. So congrats, you made it here. So the main functions we'll be using in Zoom are the chat for all relevant topic discussions. But then we also want to hear your voice. So if you're comfortable speaking, feel free to unmute yourself during the conversation and jump in and talk with us. This event is all about collaboration anyway, so feel free to unmute. And if you're not speaking, go ahead and put yourself on mute just to avoid any background noise. And then an open source tool that we'll be using throughout the duration of this event is called an Etherpad. So we'll have one Etherpad for each session, and that'll be the spot where we take notes, gather feedback, and record action items so it lives into the future. And that Etherpad will also have a spot to put your name and email address if you're comfortable being contacted after the event, and then please add an asterisk next to your name if you're comfortable speaking. That way our moderators know that they can look for you and make sure you have the opportunity. And then as a friendly reminder, this is an OpenStack Foundation event, so we do abide by the OpenStack Foundation Community Code of Conduct. So just as a reminder, please be courteous, conduct yourself professionally, and respect each other. And if you need to report any violations of that code of conduct, you can report it there at the URL at the bottom, openstack.org/code of conduct. And I will turn it back over to Allison to thank our programming committee.
Thanks, Ashley. Yeah, I want to thank the programming committee for the Containers in Production Open Dev. This group of folks has been working for the past few weeks preparing the topics for this event, as well as recruiting some of the moderators. So a huge thanks to them as they prepared us for today's discussions. I also want to thank our OpenDev sponsors. Not only do they make this event possible, but they also made it free and easy to join. So thank you for sponsoring the event, and we'll see them at the summit. All right, before we kick off day 2, I wanted to just provide a brief recap of day 1. So first, we had a lot of folks register for this event. We were really excited by just how diverse the audience was. We had over 700 people register from over 70 countries and 470 companies, which is a great group of attendees to come together and discuss containers in production. So yesterday, we kicked off with a demo from Ant Global that used different open source projects to monitor container usage. They leveraged Kata containers, Kubernetes, Prometheus, and Grafana to show us how they can monitor that container usage internally. Then we had a day focused on OpenStack and containers. We kicked it off with OpenStack and non-Kubernetes containers projects, and that discussion focused a lot on different elements of an environment like CI and monitoring. And then we went into a discussion around OpenStack and Kubernetes. Kubernetes is the most popular containers applications project that OpenStack users use to deploy and to manage applications with their OpenStack environment. So it was definitely a very popular conversation, and there are a lot of different integration challenges, but also different implementation strategies that the users discussed during that session. And then the last session was around the OpenStack cloud provider, and Christoph and Anusha provided just an update around that initiative and how folks can get involved. And then in today's wrap up, we'll talk about the different SIGs and initiatives where attendees from this event can get involved to continue the conversation afterwards. But for now, let's dive into today's schedule. So today we're going to kick off with a telco and network function discussion moderated by Gerge. And then we're going to dive into security and isolation moderated by Shu. So without any ado, let's go ahead and kick it off with telco and network function. I'll hand it over to Gerge.
Hi, welcome everybody. My name is Gerge Csatari and I'm working in the open source program office of Nokia. Therefore, I'm quite interested in how to run telecom workloads in production in containers. So in this session, I would like to discuss different aspects of this a bit. And as a warm-up, let's do the first poll, which is about if you run telecom workloads in production with Kubernetes already. So please make the magic and configure the poll for us. Of course, we have like two options, yes and no, and we have a I do not know and prefer not to answer. While that is happening, let me just start with some housekeeping. So I collected some topics and I would like to get an ongoing evaluation of which topic to discuss. So in the Etherpad, like in line 2030 now, you can have a vote if you would like to that topic, and every topic has a vote. If there is no voting or anything like that, I will just go sequentially on the topics. And of course, as any other OpenDev sessions, this is supposed to be an open and interactive discussion, so it shouldn't be just like me talking. So please, if you would like to comment anything, then just speak up or use the chat or the Etherpad. All right, so the first topic what I wanted to discuss is a bit of the reasoning. Why do we think that telecom workloads needs some additions to vanilla Kubernetes? So what are these like requirements, what we have and what justifies or like special needs? Because this is a continuous discussion. Like if you are using anything else than vanilla Kubernetes, then you are not cloud native and you shouldn't do that. On the other side, we have like specific requirements what we cannot fulfill without using something extra on top of in-tree Kubernetes. So I collected some of these, but I would like to ask you to add your options also. And I think the first one is quite obvious for anyone who is doing in telecommunications, and that is multiple pod interfaces. So this is something that is not supported by Kubernetes, but because of requirements from the regulatories and or because of like load balancing of telecom protocols, we need multiple interfaces in a pod, and yes, and also we have a requirement for isolating networks. Thanks for that. Therefore, we need something extra on top of vanilla Kubernetes, and I listed 3 workarounds what I'm aware of. Most probably there are more. The first two are using the, let's say, the CNI interface of Kubernetes, namely it's DEM and Multus CNI. And the third one, called Network Service Mesh, it's basically bypasses the networking of Kubernetes, and hopefully we have representatives from all of these three in the audience. I do not know if there is any other solution what we need to mention. I know that there are some other CNI projects which are targeting the same, but they were mostly dormant in the last at least 6 months when I did check those. So that is very good. So we have some kind of requirements, we have workarounds and so on. But the drawbacks are that how to put it, like there is no consistent set of functionality among these. So all of these three have a bit different view on how to do things. For example, Multus CNI has this approach that Kubernetes networks have, like, or pods have secondary and primary interfaces, and these are a bit different. On the other hand, DEM tries to handle all the interfaces in an equal way. Of course, there are some limitations of this. Maybe, I think Doug is here from Multus, so you can explain a bit what's the reason of this approach in Multus CNI to have primary and secondary interfaces. If you are in the call. But okay, that's an approach. And Network Service Mesh has a totally different approach. So Network Service Mesh is basically helps you to implement anything with network services, and that can also include having different interfaces. But for that, you have to have these the services. So and of course, all of these have different kind of interfaces. Both DEM and Multus use their own custom resource definitions, and Network Service Mesh is also using a different API to define the networks. The only common point in these three is that all of them, in this way or another, are implementing an API for networking in Kubernetes.
So, Prakash here, can we, since you put the DNM as the first topic, our first link, and can we not go through that as bit?
Yes, sure.
So that it's easy to follow, and then we can go next to the Multus and then to the next one, and we can add more. Thank you.
So you mean that let's talk about that a bit, and okay,
then,
we can. Yes.
Yeah.
So then is a CNI multiplexer or CNI meta plugin, which works in a way that it abstracts the CNIs, which means that in the pod annotations, all the CNIs look the same. So it doesn't use, let's say, the raw CNI annotations. Also, it implements a networking API. So if you install them into your Kubernetes cluster, you will have a network API, which is like airbag aware and all these goodies in your Kubernetes cluster. And it also implements a cluster-wide EPOM, so it manages the IP addresses in the whole cluster in a way that there will be no overlap of IP addresses in the allocations, even if you use different CNIs to allocate the different ranges. So there is a central component to manage the IP addresses, and there is also a component in them which implements cleaning for your interfaces. So if your pods are restarted because of some server or something, then there is a cleaner, let's say, plugin kind of thing for them, which cleans the network resources. And also, it also has an IP VLAN CNI, what is like an optional component. So it implements lots of telecom needs. The second one, Multus, it's also a CNI multiplexer or CNI meta plugin. It works in a way that it uses the raw, let's say, raw annotations of the CNI plugin, so it doesn't abstract the underlying CNIs. It basically like based on a configuration, it calls the pre-configured CNIs with their parameters. So in this way, you can have several interfaces in a single pod.
Basically, yeah, Alok this side, we kind of basically creating the network attachment definitions, right, and then give it to the annotations of the pod.
Yes.
With Multus.
And as opposed to them, Multus relies on an external component for the centralized IP address management called whereabouts. I put the link there. Anything else about Multus? Maybe I forgot something about that. So if we have a presentation from Multus, then.
George Lee, hi, hello. Felizardo Ferreira here. Hi, hello. Just a quick question about the protocols. In AppCam LMAP, we are talking about Citran. You didn't mention it in other parts, but it's also feasible with the Kubernetes, right? Or it's already considered like legacy?
Both of them are possible with Kubernetes, but with some limitations. Okay. You will not get like the built-in load balancing of Kubernetes. You will not get ingress and egress support. It will depend on your CNI plugin if you get network policies, if you use these protocols. And also you should be aware that there is an HTTP support implemented in Kubernetes, meaning that you can like inform Kubernetes that your ingress or egress uses HTTP, but this feature is in alpha stage at the moment. But you can use, so we have products which are using these protocols and running on Kubernetes. It's not impossible to use these protocols. It just let's say there are some gaps in the functionality, and you need to select your components well.
Okay, thank you.
So the annotations that you mentioned can be invoked in different namespaces, right? Is that,
Which annotations?
the one related to Multus we were talking right now? So you do have in the metadata the definition of this the CNI
Mm-hmm.
Yeah, it's
and the network names that is the Kubernetes network, this one, and followed by the annotation, and that associates with a particular namespace when you launch it. Correct? Is my understanding correct?
I don't know Multus that well. This is correct for Dan. But we
Okay.
had somebody from Multus, maybe.
So what happens? Multus is supposed to support the two interfaces, right? Multiple interfaces, not just one interface.
Yeah, both of these, both Multus, Dan, or Network Services Mesh are offering you the possibility to configure several interfaces to your pods.
So will we have one annotation per interface, or it will be just one annotation? Or how do you distinguish?
No. Yeah, no, there will be at least on. So I can talk about how Dan is working because that's what I know.
Okay, no problem. CNI, if you speak, that is.
I'm not even an
applied.
expert of that, but in case of Dan, you will have an annotation per interface.
Ah, okay. So you do have annotation pair there. And
Yes.
And that's the same with Multus.
Okay.
Right?
Okay.
It both relies on the same standard that has been defined by the network plumbing working group.
Okay.
Isn't that correct?
Okay. That's what I wanted to make sure that I understand when you talk about two interfaces, they are defined. So they are part of the definition in the specs.
Yes.
Okay. So the other point, once you define that and once you launch it, is it for, why do you need a daemon set? Is it going to be applied to every node? See, it says
like the daemon set of.
yeah,
what?
daemon set is for application, right? You apply for every node, then you use daemon set. That's the kind.
Yeah, but in Kubernetes, you might even consider, for instance, the CNI to be an application. Effectively, even supporting components of Kubernetes are no different to anything else. They have to use these features. And so when you're doing something like networking, where you want every pod to receive the facilities like, for instance, additional interfaces, then you need a daemon set to help you along with that. So that's something running every host that can actually do the helping work that needs to be done.
Okay, so that is the service network concept of deployment, like deployment, daemon set, stateful function, whatever, a job, then you have cron job and so on and so forth for different aspects. So every object is definitely you have to treat it everything as an object. So this is an object, even a network is an object. So CNI plugin allows you to add that. So for multiple interfaces, you have two definitions which you have to plug in the YAML file to deploy them across the node. So my I'm just thinking aloud that if we have a node, a cluster basically with multiple nodes, all nodes must have two interfaces. Is that a requirement, or you can do, some of them may have, some of them may not? Is that doable, or what's the concept here?
It's doable. So like everything else in Kubernetes, this is like very hackable, let's say. So you can basically achieve anything. So I know about clusters when, for example, one node supports them while the other node supports Multus. And even like you don't necessarily need to have several physical interfaces, you can still have multiple pod interfaces for whatever reasons. And it's up to your underlying CNI configuration. How do you steer the traffic from the pod interface to the external world?
Okay, so the service network to the pod network, when you come to pod network, if you define multiple, of course, a node, I have 2 nodes, let's say I have 3 pods, and on one node I may use daemon set to deploy what you call the CNI with Multus. On the other node with 3 pods, and those pods I may deploy with daemon set, but they may not use the Multus. They may just be bare single interface. So that's the way you look at it. Or the other way, the question could be, I have 3 pods on a node and 2 pods are Multus and 1 is not. Is that doable? That's my question. So
Hey,
heterogeneity at that level.
Both of them are doable.
Oh, okay, good. So that means that allows us from the telco deployment point of view, we can choose to have multiple CNI on the same node, and
not on the same node, in the same cluster.
Same cluster. Sorry. So not on the same node. So per node, you need to define which kind of CNI you are going to use.
So one question quick. Hey, how's it going? This is Doug Smith. I'm a little late here to join, but I'm one of the maintainers of Multus and member of the Network Plumbing Working Group. Hey, Gergely, how's it going? Here's something to consider strongly is what you probably don't want to do, and I'm sure there are exceptions, but generally you would want to have the same quote unquote default network. And when I say default network, I mean the network that you use for pod to pod communication. And it's because it's really a promise that workloads are given in Kubernetes is that they're going to have access to other pods in the across the cluster, right? So your default network, the CNI plugin or whatever else you use that gives you that pod to pod connectivity, you don't really want to break that promise. And so that's something that I would recommend. But for whatever you use for additional networks, doesn't necessarily have to have that promise. So generally what you would do is you would have a uniform default network, default CNI plugin that's run to create your ETH0 on each pod for every pod on every node across the cluster. And then what you do is you selectively add additional network interfaces and network attachments really to the pods across the cluster.
So does it impact the IP management, IPAM on this? Because you will have 2 IP addresses or it'll all be same IP addresses?
So you will have to, and so that's something that at least under a Multus scenario, you'll have to manage a little bit. And so, you'll have whatever IP address management, IPAM for your default network. And so like to use Flannel for an example, it's like you can set it up so you have like a range per node, stuff like that. With Multus, generally there's 3 paths that you can take. You can apply those IP addresses statically, and you can do that in a few different ways. But like for one example, in order to say you're going to use an additional Multus interface, you annotate your pods with a specialized annotation that we call networks. And you say, okay, these are the additional networks that's going to have. You can also use a CNI runtime configuration to say with an annotation, I'd like it to have this static IP address. So that's one way. Another way you can do it is with DHCP. So there's a DHCP IPAM CNI plugin. So if you have on these additional network attachments, you have access to a DHCP daemon, or you run a DHCP daemon, you can do it with DHCP. Or additionally, there's a project that I started and gaining some traction with that I call Whereabouts. And generally the gist is that Whereabouts does what the host local IPAM CNI does, which is a popular reference CNI plugin for IPAM. But host local works with a local flat file store that's local to each node. That's why it's called host local. And that proves to have some limitations. So what Whereabouts does is it essentially takes that model, but it stores your IP address allocations as custom resources, and then it applies IPs to your pods cluster wide, and it knows how to, tell if an IP address has been allocated across the whole cluster, and you just specify ranges and exclusions and stuff like that. So you have a few different options of how you can do it.
So in this, where is the place for daemon set then? Daemon set works with the host, local host set which you establish for IP?
And so on a daemon set, you can annotate a daemon set and you have all of those same options. So you can do static with multi-static DHCP, or you can use Whereabouts for any of those on a daemon set, or any other type of deployment.
Yes, DEM is a bit more opinionated about the IP address management, so then it has its own IP address manager, what is recommended to use. Okay.
Anything unique about Multus? Especially, is it that you reserve one for, especially in telco, we tend to do in management network is separate from a control plane or whatever. So at the overlay level, these are at the overlay level, or are these at the underlay level?
It depends on what kind of CNIs do you use under this. So both Multus and DEM are so-called CNI meta plugins or CNI multiplexers, which means that they are basically managing other CNIs, and the used overlay depends on what kind of CNI do you use. So you can use both of them with, I don't know, Calico, Flannel, but also with SRIOV CNIs or the user space CNI.
I see. That's interesting. So all overlays with different interfaces can be programmed based on the way you want them to be used. Like ETH0, as you mentioned earlier, could be for the management, and the remaining we can use it for the tenant facing or something.
Yes, ETH0 is a bit special because Kubernetes has this assumption that it can do all the status checks and monitoring on that interface. So the CNI that you use there, which what we usually call the default CNI, should be a CNI which, let's say, fits into the basic assumptions of Kubernetes. So it should be like Flannel or Calico or something like that.
Yeah, so maybe we can take it as management and workload interfaces.
Yes, yes,
for
exactly.
For the sake of simplicity. Yeah, got it. Thank you.
All right, then anything else what we would like to discuss about multiple interfaces? We have this.
Yes,
Yep,
yes.
go
For
on.
the multiple interfaces, I would like to know if you have a underlay network, which is a VXLAN, and in the overlay we are using for the CNI the pod. So what's the communication between the two? Is it broadcast traffic, unicast traffic, multicast traffic, or is just forwarding? Are there any thoughts on that?
This also depends on the specific CNI implementation.
Okay. So it is CNI specific.
It is CNI specific.
I think that in my experience, this is one of the problems we get with where we are today. And obviously, this is a bit of a shifting landscape here, that we can't say this is a network or this is an overlay and ultimately end up with a certain set of behavior. And I don't think anyone's mentioned NSM much, but NSM takes a different assumption, which is that every interface is connected to one other interface somewhere else. Everything is a point-to-point connection, which is a different way of approaching the problem. But, it's where we haven't got standardization yet and we need it. We know we want these interfaces effectively to reach different things, if you like, to get your packets treated differently if you use a different interface. But some of this stuff, because we've got these different approaches, if you're building an application, you don't know which one of them you're going to find. And since you don't know which one of them you're going to find, you don't know how to use them. It becomes incredibly difficult for a CNF builder to actually figure out what facilities they're going to have to work with. So standardizing things like kinds of network behavior specifically would be really useful to try and work out how best to put this to use.
What do you mean on kinds of network behavior?
Well, it's interesting because OpenStack had this problem and it sort of went silent there for years as well. But I mean, if you look at OpenStack, it kind of assumes that everything is a bridge domain, except it doesn't. It never actually wrote that down. So do you get multicast? Do you get broadcast? Well, maybe, but maybe not. There are certainly in OpenStack implementations of networking where multicast doesn't work. And in truth, a lot of these network connections that we're looking for NFV specifically are not connections between pods so much as they're connections to things like overlays, MPLS overlays or whatever in the outside world, not necessarily anything to do with getting one pod to talk to another. Sometimes you need that as well, sometimes you don't. It varies. So the standard saying what kind of network is optimal for your use, whether it, for instance, a point-to-point would be most useful, whether broadcast or multicast is needed or whether it isn't. Those things, there's no common way of saying that's the kind of network that I'm looking for today.
But you do have BGP, right? Which is forwarding anyway. So
well, what do you mean by you have BGP?
BGP, you have the BGP, what you call forwarding, which you can apply. Example in Calico.
Yeah, Calico implements its networking using BGP. But if I wanted to,
yeah, if you want to do MPLS, then obviously you are in the 2.5 space. So I don't know how you do it. I have no clue. Maybe Ian, it is right.
It is Ian, yes. And
yeah,
go ahead. And the point is that in actual fact, and here you get philosophical questions. My philosophy here is that we really want to extend Kubernetes only as much as we absolutely have to, to make it serve our purposes. So if you want to talk MPLS, then it may be not about trying to make Kubernetes magical and special and fully understanding MPLS or adding a plugin to make it understand MPLS, but actually being able to talk to the top of rack, the PE or whatever you're attached to, and getting it to help you along with MPLS. So really just attaching in the right way to the top of rack and then using, SDN in a more traditional sense to make the top of rack do whatever it is that you want to do. That would be one approach, for instance, that could be made to work. Or conversely, if I want MPLS to be done by software, then maybe I bring along a container that actually does the MPLS encap for me. And what I want it to do by itself is I want it to do the BGP speaking versus necessarily, again, building it into Kubernetes. Because then you can install the component you're looking for, but ideally it's not a part of the platform. You can support it as without it necessarily having so many privileges that it can break every other part of the system.
So even if you do MPLS, you still will be doing at the MAC level, right? At least on the containers.
I mean, you would need basically a very clean way of getting your packets in and out, yeah, you'd be down at the lowest level of network protocol where you're just saying, I'll give you a packet and your job is to get it to the outside world without touching it at all. And there's some very serious limitations on that. Again, MPLS really doesn't work over bridge domains. So that very much has to be a kind of point-to-point link to the next MPLS speaking device. So it imposes a set of networking that Kubernetes has never been intended to support. I mean, your average application designer who uses Kubernetes, the ones who developed Kubernetes, the Kubernetes we have today, aren't interested in MPLS packets, they're interested in web apps. So, you know, we get what we're given, but we have to understand it's not going to be complete for our needs.
No, we understand that it's not vanilla Kubernetes deployment. Essentially, is it going to be host native, or is it going to be container native that you need to apply for MPLS? That was my question.
It depends what you mean by host and container native.
So
I'm saying
you embed the whatever your MPLS agent in the container, which is within the container.
Yeah.
And deal with it.
Yeah. So what I'm saying is that if you consider running something into an MPLS overlay as a network function in its own right, one way of doing that might be to have a network function whose sole job is that, and you need a platform that enables you to do that. It doesn't mean to say you have to build MPLS into every single network function.
Maybe we will take this offline. Yeah, thanks.
Yes.
Sorry, that gets into deep conversation. Apologies for that.
Let's move forward because we have some other topics with lots of votes. So on the requirement side, let's move from multiple pod interface to the network API. So this is one requirement what I think we need, and I think we need because we need integrations with SDNs and we need kind of a dynamic management of networks. And we have surprisingly the same three solutions for workarounds. Plus, we have a network operator on OpenShift, which basically can provide you an API for the networks. But again, with similarly to the previous problem, the drawback is that all of these have different APIs. Best solution would be, of course, to have one API. I don't know what people think about it.
Yeah, I agree. Let me just for a quick preamble. This is Doug Smith again. One thing, and you know, maybe this was covered a bit, but you know, something looking at like a DNM and looking at Multis, you know, something that you'll that I think to me at least appears very clear is that DNM is more opinionated than Multis is, and it kind of has more built in, which I think is really great for bootstrapping. And I think that you know, Multis is maybe a little bit more modular and a little bit less opinionated. And I think that there's benefits to this, and this is something that we can see in ecosystems across technology where you have these kind of options. And something that we do with the OpenShift network operator, which we call the cluster network operator, is that we kind of add an opinionated layer on top of Multis. So the cluster network operator does use Multis behind the scenes. And what we do is we have some kind of self-driving type of features which say, hey, this is the way that we'd expect you to use this technology, and give you a way to do that. However, that being said, I mean, Gergely has a great point, which is, you know, we're fracturing. Right now, we have a fractured experience for users, for engineers, for people developing CNFs, et cetera. And with the custom resource definition, so here we have it as a Multis CRD. One thing that's kind of important to note is that Multis is a reference implementation of a standard that was created by the Network Plumbing Working Group, and we've created a CRD standard that we call a network attachment definition. And so there's a few other implementations out there that use this as well, but this was one thing that we were trying to aim for, is to standardize this experience for users so that you can express that you'd like to attach to a network, but if you change the technology behind the scenes, you still have that. And so I think it's a worthy goal. I think that we've made progress there, but I still think that that there's a further road to travel here, and I think that we still have an opportunity to come together as a community and come up with a way to say, hey, let's have a broader way about talking about networking in Kubernetes, a broader API for that.
So Doug, question to you on the Open Shift. When you use DHCP-less, that's good for lab environment, but what happens when we don't want DHCP-less?
So right now in OpenShift, you have the same options that I mentioned before for Multis, since it's using Multis behind the scenes. So if you don't have DHCP, that's okay. You can use Whereabouts for IPAM, so that'll just use custom resources to hold those IP address allocations, or you can use static. So that's same gist, static, DHCP, or Whereabouts.
See, so it's all three of them adopts similar approach. Okay.
Yep. Good question.
Okay.
Regarding network API, I would like to add one more thought. This is Jan speaking. If you compare the situation to what we have in OpenStack, yes, we have a network API called Neutron, and then we have the implementations below Neutron. And when you create a network in Neutron, the backend really does all the work that is necessary in order to make this network really operational inside OpenStack and also on the platform that OpenStack runs upon. That's the expectation. And I think that is very different from what we have with the network APIs in Kubernetes today. I mean, the DAM and Multo CRDs, you create network attachment definitions so that the networks can be consumed by a pod, but they don't do the work to really set up all the networking, the host networking and the fabric networking in order to make a network really available end to end. And I think that's a big gap, and we need to understand that. And it's worth talking about how can that be addressed.
Do you have an opinion? How can it be addressed?
We are kind of working on a proposal on how to model a networking API that is kind of expressive enough to write backends that can do the actual work on the host networking side to configure the CNI, and also to maybe to talk to Fabric to configure a Fabric, similar to what is done in Neutron today.
So where are you working on that?
Right now, this is study work that is done in-house in Ericsson.
Okay, because I think that's a place where the community should be coming together, not just in terms of API definition, which I can see is important. As we say, we're all taking slightly different approaches here and they're slightly incompatible with each other. But also, again, what I was saying earlier on requirements, we tend to start with, like we did again in OpenStack, with the assumption that the networking we're given is the only networking we might ever want. And again, NSM has taken a very different path to what CNIs offer to try and deliver something additional. So maybe making sure we actually got all the requirements written down and agreed, as opposed to assuming we're all thinking in the same way.
Can we agree in one group where we do this?
Pick a group. Apparently not.
Right now,
not
what we're looking at from a modeling perspective for this API is the setup of primary networking with the focus on making the primary network able to access external networks and the multi-secondary networks. NSM is not yet in the scope, but of course that's something that what we want to do.
I would argue here that as I sit and watch, that the CNI approach is not obviously the right one, and the NSM approach is not obviously the right one. I just want to make sure that we have those requirements thought out, because trying to basically, without the requirements definition, can you honestly say you're doing the right thing? You've got nothing to measure against. And I know I'm saying that in front of an audience of people who write this for a living, so I apologize in advance for causing great offense.
Not to me, Ian. I think that that's totally fair, and I think that these are, that it's like we do have approaches. We're coming at them from a different angle, but if we have like overarching goals, requirements, etc., I think that we can, better serve the greater community by identifying those. I think that that's an astute observation.
So I think it's the WAN type which is causing the problem here, I believe, based on what Ian says.
Well, I'm not necessarily saying it's hard to deal with a WAN, but that is one question. I'm saying that things that the CNI doesn't let me say today is how I'm attached to the world, because it never needed to, right? I've only got one point of attachment. There's only one way traffic comes into Kubernetes with one CNI. So that is a problem in its own right, and that's a fair point. But then when we talk about CNIs and whether or not we're using VXLAN and this, that, and the other, whether broadcast works or doesn't, a lot of these things actually, as an application designer, I actually do not care what my NCAP is a lot of the time. I don't care if my management traffic goes over VXLAN or not. I care that it's isolated from everybody else to an extent. Some of the other stuff, again, if we were talking MPLS, it's not that I care or not whether it goes over VXLAN, it's that it's probably not going to work if it goes over VXLAN. So my networking requirements drives the implementation in some of the cases, and in other of the cases, the implementation doesn't matter to me at all.
See, we went through this in the Neutron. We remember that whether we should do for ODL the label or the support. So if you look at it here, what would you, we already use annotation, right? That's the understanding here. So does it not meet the requirement then for, question is about multi-networking. That's right on the WAN. Do you need a support or do you need a, anyway, IP level, it is all single pod is a single IP, right? So it's just a matter of which port you use. So
well, if it's MPLS, it's no IPs at all, which also adds to the confusion.
Yeah, that's the reason I asked you beforehand. Do you have any container native whereby you can, instead of CNI, you can really pseudo CNI it and make it MPLS for you?
No, I don't have an answer for this problem. I just have the question right now.
Yeah, I think we will not solve this, but let's do it. And I don't even know like in which group should we start acting on this, but let's do it in a way that if you're interested in this kind of alignment work, just add your email from line 91 and I will start about this.
So Gerge, I have a question, because I was the one who was kind of going back and forth about the responsibility. I mean, I haven't been participating in the CNCF tug, so I don't know how strong it is and how and if it has enough resources to do that. And I know you have been, so could you maybe comment on that?
So far CNCF Tag did like a prequel of a white paper, and CNCF Tag somehow gets reports on the work of the CNF conformance test and CNF testbed, which is basically done by a set of developers, including Taylor, who might be in the call, but I cannot see him. But the tag itself.
No, Taylor does say he's here.
Hi, Taylor.
But it's, yeah, if you look at these groups, right, the Taylor can only test what we've built. So, you know, he can prove that this is a workable idea, which is certainly very useful. And if we look at CNTT, then from what I've seen, the CNTT's, well, it's got odd titles for its documents, but again, a lot of the requirements came from OpenStack and are very, very brief things like must support service chaining, which is difficult to work with.
Yeah, let me address that. So CNTT started with the OpenStack as its first reference model. So we have reference model and then we have reference architectures. The reference architecture we started with was OpenStack. That's because, you know, 99% of the telecoms are using OpenStack today. So it kind of makes sense. We are actually working on a second one, a reference architecture that's specifically Kubernetes and containers. So,
but my question is, again, from that requirements perspective, how do you know when you're done if you don't have a list of things that it must do or it must be capable of doing?
That's where
CNTT, so CNTT is nothing else than an effort to, let's say, standardize infrastructures. And it's basically how to build something from existing open source components, and not defining something new and implementing something new. So it's like, it's the purpose of CNTT to select components and configurations. Sorry, but somebody is typing very hard. I don't know who is that, but
somebody's a really good typist.
yes. Yes, so in CNTT, we do not want to invent anything new. We just want to limit options. That's what we want to do.
So we're saying that we haven't really got a nominated area where we might actually, for instance, write new code to see whether that works better for our problems or define our problems up front.
CNTT will get there. So to give a little background, OpenStack, the RA1, or which will probably be renamed something, but whatever, is OpenStack, and that was where we started, and that one kind of went pretty quickly because, of course, we have a lot of experience with using OpenStack in the telecom infrastructure world. We are struggling with RA2, which is the containers, our Kubernetes, because we have a whole lot less experience. I mean, certainly many of the telecoms don't actually have containers in their infrastructures yet. Doesn't mean we're not interested. We are quite interested. And B, we are also finding that, as we're discussing here, many of the container infrastructures or the container code is not overly friendly to telecom workloads. So that's kind of what we're trying to solve here. So yes, there will be at some point, the intention is to have some things that come back into CNCF to say, these are the requirements that we need to add this functionality into the container world. So does that make sense? Yeah.
Yes. Okay, let's switch topics a bit because we have like lots of topics and I want to cover at least one more. I'm not sure if we can fit more topics into the time frame. So the most votes what we got is state of multi-tenancy for telco network functions, best practices and implementation references. So let's talk about that a bit. And to be honest, I do not know who put the topic in to the other, but thanks for that. So the best practices so far listed are using separate namespaces and using separate clusters. And there was a question about software versus hard isolation. I think the main question is about trust here, of course. So if you trust fellow workloads running in your cluster, then I believe that soft isolation is enough. But if you cannot trust other workloads, then hard isolation might be needed. And of course, also we have this issue that even if you use isolation, if you are running something in the same host and you are not using any VMM-based runtime, then you are sharing the kernel. But okay, anyways, what are the opinions about this?
Yeah, so just to add to the problem statement, I think if we have like a single vendor, which is providing all the container native functions in my cluster, then I mean we can still manage it. But however, this problem becomes even more acute when we have like the CNF from the different vendors, and that's when I think we have to think like whether we should just have separate namespaces for each CNF, or do we have separate cluster for each CNF. Now, if we have separate cluster, that will again have higher resource utilization. But maybe that is more secured and providing more isolation.
Yeah, I mean, I've had some weird conversations with some of the security folks that basically said that they wanted every single application to be in a separate namespace. I was like, well, you've just reinvented the VM.
I'm not sure that's entirely true. There are certain things you do want. You want them to be resource isolated. You want them not to be interfering with each other's internal networking. Because ultimately if you get a CNF from me, you want to be able to hold me accountable for that CNF working. And if you start interfering with its internal workings, then you're not going to be able to do that. I'm just going to point and say, well, you do that, I don't support it. So I think that's what it amounts to, that your CNFs have to be well enough isolated from each other that you can actually claim they're broken when they're broken. And a namespace might be one option, but really we're just, again, picking concepts on the table. Namespaces are probably the best fit. I think the biggest problem with running applications each in their own independent cluster, the problem with that is that one of the big advantages of a cloud platform is that it's a +1 redundancy model. If I'm running 50 applications, I only need one additional server to be proof against a server failure. It doesn't matter which application is running on the server that fails, it will migrate to the server that sits in standby because it's good for all of them. If I'm running 50 applications on 50 clusters, I need 50 backup servers. And that would be the loss if you can't get these things to collaborate on a single copy of Kubernetes.
One of the reasons why I put hard versus soft is because there's always this, like if you talk to folks that are coming from the cloud native side, right? Like the Tigera folks, they're going to talk about network policy, application identity, et cetera, as these ways to isolate. But when I talk about hardware or hard isolation, I'm talking about separation of network and some concepts that most of the Kubernetes folks aren't really trying to solve. Slicing, pinning, NUMA, et cetera, these other things, so you can guarantee SLAs in the telco world.
It's a big difference between best effort, where you can, you know, your real timeness is in the sort of tens of milliseconds sometimes, and you can tolerate that, or your end users will tolerate that. And you know, scale out is I'll just run another copy because there's an infinite quantity of cloud in front of me, and there's always a bit of spare space. Versus SLAs in the telco world, and again, we have to bear in mind that Kubernetes was written for one of these and not the other, so it's not amazingly surprising that we're coming up against these shortcomings. But in the telco world, you know, I'm not about to add an extra 5 servers to every cloud deployment that I'm running, especially if that cloud deployment is right out at the edge of my network, just in case something breaks, or because I can't pack my applications tightly. Clouds are not infinite for service providers, and we have to remember that.
So if we look into, the available solution, like we have that cluster CUTL and the cluster API, using which now it becomes very easy to manage the life cycle of a cluster. And so that is a like a recommended, I mean, a very easy solution, which is increasingly we are leaning towards. But I mean, it is good to know like what is the general view to solve, because as it stands that we do not have a best practice or a lot of references. So what's the general view, like which way should we take for the multi-tenancy for the CNF?
That's a very good question. I think we have several solutions by the different vendors. And also, I think it's important to recognize that, like, we are talking not only about increasing resources if we are using different separate clusters to isolate our workloads, but we are talking also about increasing management needs.
One thing I'm trying to calibrate is whether this problem is in some way essentially different for telcos running containers on OpenStack than for public clouds running on OpenStack, or enterprises that aren't telcos running containers on OpenStack. There seems to be, to me, to be a spectrum of OpenStack deployments between those that are somewhat public cloud-like on the one hand, and these include a lot of large enterprises, where the compute instances that are run are not under administrative control. They're not under control of the OpenStack administrator. There's really separate tenants who are renting infrastructure as a service. This is analogous to AWS or Google Cloud or something like that, but OpenStack on that kind of model. On the other hand, there are some cases that are more analogous to something like vSphere or something like that, where the tenants and applications are under control of the OpenStack administrator. And they're using OpenStack really probably because it has a nice programmable API, but they don't particularly about hard multi-tenant separation. and maybe there's some middle ground here, where some that needs to be mapped out. And so backing up my question, partly, and part of the reason I'm here is I'm very interested in this spectrum and how OpenStack deploys there, and then its implications for container multi-tenancy. When do you need hard separation, where you basically need to run separate clusters, and when can you have namespaces and essentially cooperation and trust among the tenants? And does this change for telco applications relative to the rest of them? That's what I wanted to ask, I guess, or what I'm trying to figure out.
I would answer it like this. Okay, NFV has been really bad in managing infrastructure at the level when you need to deal with the bare metal, and which was never defined for a long time. And that said, container being running over a little bit of a OS and the bare metal is not in a position until that is resolved. And I think so the infrastructure folks have to deal with bare metal, whether we like it or not. We want to be in the abstraction world without really addressing, and that is the cause of all the problem for NFVs going so over almost span of 10 years trying to figure out what to do and still not being very successful. So the same thing will happen for Kubernetes if we do not address the specifics of the bare metal. We can kid ourselves and do nothing at the end of the day. Again, we'll be in abstraction world. And to that effect, obviously drivers mean a lot, plugins mean a lot. And if the focus is on the CNI, CSI, and computes, runtime, that is runtime interface for container, then those needs to be proliferating. Obviously, we put them out of tree in the cluster API to ensure that controller is able to manage the entire objects, which is pods, and having a pod network separate as a overlay. Obviously, we are not even talking underlay right now. So underlay has to be addressed properly, and interface between underlay and overlay have to be we have to select. As a, if I'm a service provider, I'm forced to take it. Like I may choose a Calico or whatever, but that's what it is. Reality is we have to select few and then address them in a way which really becomes what you call the carrier grade. That's what I would answer for whatever you asked right now.
So Prakash, you're saying that telco, in the telco segment, there's an essential need to apply multi-tenancy to bare metal resources. And that's what would distinguish it from general enterprise cases or public
Yes,
cloud
I
cases.
think you're interpreting me rightly, because the problem with the containerization is not going to something. What was happening with virtual machine is not going to disappear overnight because we brought container. The problem of networking still remains. You need to have some virtualization, some isolation, some security, and trust, which is what the final word comes down to. And if we cannot plumb that properly, we are again going to extend another 7 years or 8 years before we get to containers at production level. That's my prediction, unless we address very aggressively on what matters most and get the highest priority and focus on that and get that out of the way. Probably we'll have to actually, as a follow-up, we must do something to see where we can go from here, because this is a movement in industry where we can miss the boat again, like we did in the case of VMs.
But what kind of action do you envision?
I think we need to have a group follow up on what exactly will take us to the NFV grade, because we agreed that vanilla grade Kubernetes is not going to serve the NFV. Yeah, you can go and put in your public cloud any number of vanilla grade, but then the cost of it is that the cloud provider will enhance your operation with the hardware they have or infrastructure they have, whether it be switches or routers or whatever underlay. Now, if that has to come to a service provider, that is a carrier grade service provider, as we talk of Verizon and AT&T's of this world, or China Mobile, then what they need is the similar capability which the cloud providers have, and they cannot do that unless we pin down on a specific way the infrastructure and underlay, that is a bare metal, talks with the containers. Like we have for the VMs today, we can confidently say that I can put a VM and I can even go to the Kata if I want security, but the same cannot be said of container today. And that's where we need to get the industry moving. And service providers are key to this. If they come together, then the vendors come together. If they don't, then vendors don't. That's the way it is. So we need the service providers to participate. They can say that I want X or Y, two options, maybe whatever that option turns out to be. And we as an industry try to see that we don't fracture too many, just focus on one or two options. And service providers settle amongst themselves that, okay, I will have X, I will have Y. That's it. Otherwise, we are in for a long haul, as I see.
Okay, so to move forward with this, what I can offer is to again collect a set of emails and start a discussion on how to continue. So if you're interested, then just add your email address from line 153 and we can take this offline as time is ticking, and I think we need to stop the discussion in 12 minutes.
Sure.
All right, any other comments on multi-tenancy and workload isolation? If not, then let's move to the next topic, and based on the different polls what we are running here, the next topic what we should conclude in around 10 minutes is the network acceleration in Kubernetes. So currently we have like on the CNI like universe, that's what I aware of. We have solutions for SRIOV, we have solutions for user space, both VPP and DPDK, and we have solutions for specific smart NICs using Kubernetes device drivers. I do not know if we have anything on top of these, or if we have any like silver bullet kind of solution. But if somebody have an opinion, just please speak up. And we are at line 114 in the Etherpad. So for example, I was a bit involved in the user space CNI in the beginning, but I do not know to where it did evolve. And I guess, Doug, you were at least involved in that. But as far as I remember, the aim there was to provide like a generic framework for user space networking solutions. And create a kind of plugin architecture where you can plug your solution in. And we had plugins for VPP and DPDK.
Well, so let me ask a basic question here, because it seems that almost all of the things here are listed are hardware solutions. So can we in fact accelerate networks without hardware?
Well, then what's the definition of accelerate here? But I think the question
I asked
is,
the question.
yes,
What's hardware?
how about phrasing this differently, right? How can you do the job you're looking to do for the least cost? Because that's what it comes down to. Is general purpose compute always the cheapest way of making this work? Well, not at Intel's prices, with apologies for whoever's from Intel on here. Smart NICs, theoretically, FPGAs, theoretically, actually using the network devices that your cloud is connected to, theoretically. You should be using all of these resources. They're right there to be used. They have nothing better to do. But you need to, find the sweet spot, the one that has an operational complexity because it's cost as well, that you can cope with, that lets you do your job with the least expenditure in hardware, and possibly more importantly, the least expenditure in ops, because that's the ongoing cost. But I mean, you need a scoring mechanism, and the scoring mechanism here is how many dollars are leaving your pocket. So, am I going to spend $2,000 on a smart NIC when actually if I spent $2,000 on extra CPUs, I would basically come out even?
Right. Well, one could argue that a smart NIC is essentially you've moved the CPU into the smart NIC, right?
All right. Smart NIC is a label that is almost meaningless. If I went and bought a bunch, I can buy a smart NIC which has a 64 ARM processor on it, and then really what I'm getting is more CPU. Or I can buy a smart NIC which is a whopping great FPGA, at which point what I have is very much not a CPU, and it's got different strengths and weaknesses. And frequently that's entirely use case specific, and now unfortunately I end up with a cloud that is tailored to the workload if I'm not careful.
Yeah, but it's not just the hardware, right? It's the abstraction and being able to abstract. If you have heterogeneous compute elements or network elements or even storage elements, then the issue comes down to how do you write the software. And software is not revolutionary, it's evolutionary. And it takes years before we can deliver something reliable for a carrier grade usage. So the issue comes down to narrowing down the gaps in the variations that are possible, and that one claims to be better than the other approach.
But it's a moving target, right? Because as hardware costs are coming down, so Ian is absolutely right. Eventually it's like, okay, well the hardware is so cheap, we'll just throw hardware at the problem.
Yeah, hardware are cheap, but if you ask for a GPU, they are not cheap. If you want to increase the compute power. So it's not a question of hardware is cheap, it's a question of what is the hardware.
Yeah, well,
I think one of the problems we run into here is also the units we have to deal with. So GPUs don't have to be stupidly expensive, but the big posh ones that are helping you along with compute typically are. But the thing about GPUs is it's one massive unit of silicon that costs you a lot of money that ultimately, as things stand today, is going to accelerate precisely one workload, which is a lot of money for a very specific use case more often than not. And the similar with smart NICs, right? Uplinks, a smart NIC, if I wanted to throw 10 smart NICs as opposed to one in a server, somewhere I'm getting 10 ports, I'm getting 10 sets of wiring, I've got a whole bunch of, again, operational details, albeit probably technician's time at that point. So my unit of smart NIC is typically of the order of 1 or maybe 2 per server. you know, and that's a lot of resources that I am probably handing off to a single application again. So in some regards, it's not that the hardware itself is so expensive as that the hardware can't be subdivided like servers can be.
Well, there's another factor which I saw in the Zoom chat, a bunch of people brought up. It's not the, you know, the hardware itself is generally fairly inexpensive now. You know, that's been going down for a while. It's the cost of ownership of that hardware, the cost of running that hardware. You know, that's what drove cloud and virtualization, which is we had a bunch of spinning disks and a bunch of hardware sitting around not being optimized, right? And so that's what cloud's all about. It's optimizing the hardware you have. So, you know, I think that applies here too. Are we optimizing the network workloads, which are a little bit different than cloud workloads in that they tend to be more consistent, right? They tend to be more even. You don't get the spikiness that like web workloads get.
Exactly. I think Beth has put the nail on the coffin. The issue has been the location of the network and the corresponding resource requirement. And that tends to be different at different location. And with the emergence of edge, again, delivery by edge, that's causing another aspect. How much of computation do I need? How much of power do I have? How much of steadiness I need? And so the issues is not just the computing, the software, but the ability to deliver at an optimal cost. And optimal costs are different for different network locations in themselves, where the delivery of service is another. What service? Are you doing streaming? Are you doing something AI, ML? So workload differentiation along with the location differentiation. We need to have some metrics to say that at least minimum this much compute is required with these applications.
That's a very good, very valid comment. And I think that also depends on like how do you schedule your workloads. But unfortunately, we will not be able to solve this today because we need to stop in 2 minutes. So thanks for all for the very good discussion. So as a conclusion, we had a short discussion about the requirements what we have touching the multiple pod interfaces and the network API, and we agreed that we will continue the networking API discussion. So if you're interested in that, please add your name to the list from line 96. We also had a discussion on workload isolation in Kubernetes, and here again we agreed that we will continue offline. So if you're interested in that, please add yourself to line 163. And we also had a short discussion about acceleration and different technologies to increase the performance of networking. And with this, I would like to thank you all for the discussion. I think it was very useful. I learned a lot. And with this, we can conclude the meeting. Thank you for all.
Thanks. Thanks, everybody. That was great. We'll circle back on a lot of those follow-ups after this next session as well before we wrap up today. But for now, we're going to take a quick 5-minute break. So we'll put a holding slide up here and we will see you all in 5 minutes to talk security and isolation. All right, welcome back, everyone. Now we are going to jump into the security and isolation discussion moderated by Shu Wang. So I will hand it over to Shu now.
Hello, everyone. I'm Shu from Ant Financial, and let me do a very short introduction of myself. And I'm from the project Kata Containers, which is known as Secure Container. And yeah, I'm working for the Ant Financial, and we are working on to deploy the Kata Containers, secure containers inside our organization. And I think we are the technology not only for the security, but also for other isolation technologies such as the performance isolation and failure isolation and so on. And today, let us talk about the container security and isolation. That's not only about the Kata containers, but also other container technologies. So from the beginning, I think we may go through some ways to improve the security of containers, which is about protect the host from the malicious container applications. And yeah, for the runtime technology, and if you use run C, I think the default one will be the seccomp. And also you may use the runtime class to select the so-called secure containers, such as the Kata containers and Google gvisor and so on. And so about the application classes, yes. Do you mean the per application VM cluster or bare metal cluster? Right.
Hi, that was me adding that in. Yeah, the per application Kubernetes clusters, it was something that came up as a pattern yesterday, was kind of treating Kubernetes clusters as cattle. So it's a bit like if you go to a public cloud and you just spin up your own Kubernetes cluster. So yeah, the isolation is from the infrastructure IIS level rather than within the cluster itself, just as an option.
Yes, for large organizations.
Massive overheads.
Yes. For large organizations, that could be a solution for that. Even though that if we try to build more depth for the security, we still want to add more security boundary for the runtime. Anyway, I think the per application cluster is one solution for the maybe some security applications that need to be isolated from others.
It's a sledgehammer, isn't it? It's quite a big thing to fix the problem with. But...
Yeah. About the seccomp. Is there anyone want to talk about the seccomp part? Why this one? Should we group into the runtime and build time? Yeah. Yeah. Actually, I think there are some ideas to do some real-time analysis about the applications and to check the ideal SecCom configuration for an application. I think that for some organizations, the ones who develop the applications and pack into Docker image and the one to operate the cluster are different. For those developers, they maybe they don't want to add too many restrictions for the images and for the ops. Maybe they don't have the time to, they don't have the enough knowledge or the skills to get all the detailed configuration for the images, and that works for some situation, but I don't think that's really applicable for all the users. And I'd like to ask who added this one, and do you have some explanation for this? Yeah.
Are you talking about the SecComp?
Yeah.
Oh yeah, I was speaking more generally, not really SecComp and SecComp specifically. So like as I was looking at the list taking form, you know, some of these things are more like runtime protections or runtime considerations, and others are, well, I think when you're talking about security, you can't talk, like you can't not talk about the build as well. So
that was my reason why I put that note.
Yeah, I didn't really have a good place to put that. Like maybe we should separate it, well, not even separate, but just consider runtime and build, because I think some, at least from what I've seen in working with different customers, is that security is so big and so broad that you know, I've been on engagements where you're literally in front of a team of people and it runs the entire gamut of like things to discuss, and I think that they all kind of fit nicely together for a more complete solution, including separation of what is considered CI versus CD and what gets into CD and how policies can be implemented, you know, maybe in separate repos, how you would do GitOps models. It's just such a wide topic.
Yeah, and in our team, we are someone working on something like the supply chain of the applications. They do things is about to when the develop time and the integration time and build image and try to ensure the image itself is secured, and then before the container is launched, they need to check is this the unchanged image to be run, right? And actually, I listed the item below. It's called about image and would have a security part, and also maybe there are other parts in the life cycle about this, maybe. Yeah. And
I want to ask, when you say you want to separate runtime and build time security, what what kind of the scenario, what's the scenario you are thinking for build time? Can you put up an example for that?
Users, groups, things like that. Like when a customer would say, yeah, I want to run this as non-root. What does that look like? Because that has impacts to the build time or what users may be used in the build process. Let's say you want to do GPT signatures on container images, build time, things like that is kind of what I'm thinking of.
So mostly the image signing, right?
Yeah, one example. Yeah.
Yeah. That makes sense.
Yes, that's part of the security. And also I'd like to mention is all the above parts, we talk about the runtime security. That's about to protect the host from the guest. If the application is some exploit here, or maybe that's a malicious image that may attack the host. However, there's another direction. That means if the host has been there is an exploit in the host, then the malicious program on the host may get the content, or maybe do some denial service for the guest. So there may be some part of the container security is about to protect the container applications from the host. That's another part. And right now, I think that may depend on some hardware features such as XGX and AMD ICV and MKTME and maybe other hardware architectures. Yeah. Is there anyone interested in this part?
And some of my opinion, I think for containers entity, on one side is technology issue, on the other side it's a kind of use case issue. So when we have a T environment, what's the targeting use case we want to implement? For example, with that in mind, we can have different technology implementation. For example, the Amazon enclave, that's a different enclave technology than T or SGX we might think, but that kind of fits into the secure scenario as well. Yeah.
Mm-hmm. And let's look at other topics. And another topic I listed here is about the overhead or drawbacks introduced by secure containers. And yes, because I'm working for a secure container project, and I think every day I receive these questions about the overhead of the secure containers and how much. I also wonder how much of the overhead could you afford for your applications. And Yeah. Mm-hmm. Yeah. Let me do some summary about the currently the secure containers in overhead at this time. I think the CPU parts for the bare metal machines and with VT technologies, the CPU performance overhead will be I think normally will less than 5%, and the memory consumption will be for the latest version with I think that's maybe tens of megabytes or less. And for the compatibility, I think for Kata containers, the compatibility there will be very few compatibility issues because that's a real Linux kernel inside the guest. But for the divisor, I think there are more. And for the Kata containers, it's really depends on the VT technology or other things like that. And for divisor, there is a way to use such as ttrace to avoid the VT dependency. However, that will have a significant impact on the performance. Yeah, that's the current situations. And about the eBPF implementations, and the part of the network security introduced the eBPF for that, right? Personally, I'm not working for the eBPF parts, and as far as I know, the eBPF parts could be. I think that's much efficiency than the user space proxy things. But I think that's a competitor of the things like the DPDK or something else. And for the
yeah, one of the reasons why I brought up eBPF is because there could be considerations when we're talking about the way that policies are built. Because if it's done on XDP, that's done on ingress. If it's done on traffic control, then that's ingress and egress, which is why the folks at Tigera ended up using traffic control so that they could keep the policy model the same. But it has implications for, as you already alluded to, like kube proxy, because kube proxy isn't necessary anymore. And so then vendors would have to write the proxy-based functionality into their CNI, and it gets brought up a lot. So I know that it's on customers' minds quite a bit. I was just wondering if there's any other interest in talking about that or opinions on that.
And for the in our team, we just use the eBPF and to do some forwarding optimization or something like the matrix collections. And yeah, as far as I know, the part of the downside of the eBPF parts as the that is not really stable in the kernel space, and for some older kernels, and the API maybe changed to the version by version, yeah, and that's a bit painful for the operations, and also for the operations for the eBPF, it's does more flexible than the change the kernel code itself, but still many people think user space solution may be more flexible for the applications. Yeah, indeed, it's an important part to you may just to hijack some syscalls or some packages and to do some operations on the kernel side. That could be useful. Yeah. Mm-hmm. Yes, and for the, is there any others have some thoughts about on the eBPF and other technologies? Okay, go on. And for the performance isolation and the failure isolations, and actually for our team, we are working on deploy the Kata containers inside our organizations, and actually we are working on not only on the security part but also used for the performance isolation and the failure isolation. That means we have a gas kernel for the application, and even the gas even the container has too many threads or too many or have caused the OOM or other things that do not cause the performance QoS affect does not affect the service level of the host, and even there are some applications hit on some kernel bags that may cause the ops of the kernel. It still only affect the guest, but does not affect other containers on the same host. So that may be more useful than the security isolations for our team. Yeah. Yes, maybe too many threads or OOM things. Yeah, and is this a good time to bring up Kubernetes deprecation of security policies? Yeah.
Sorry about that one. But there's talk about deprecation of pod security policies. So anybody implementing that, I mean, since SecComp was brought up, right? If people are trying to enforce at the pod using pod security policies, then this gets interesting. Even Microsoft, right, moved towards making kind of a stand a bit without made kind of a stand, since there wasn't a lot of work being done since there hasn't been work done in a while on pod security policy. So I think it's, if somebody can kind of correct me, but it's not going to GA, so therefore it may be forced out. And so there's some talk about implementing this, or implementing security with admission controllers or OBA policies, sorry. Can somebody correct me if I misunderstood?
Actually, I'm not working for the Kubernetes security policy part. And is there anyone familiar with this part? Actually, for us, we don't apply too much things about the security policies actually. Yep. How about others? And so we don't have oh yeah, there's wow, issue number 5, right?
Yeah, that's a really long thread, but the summary essentially is that it would be deprecated.
Yeah. Actually, I'm not worked for this part, and yes, maybe I think that could be achieved by other maybe some of the other features such as runtime class and some other parts to combinations to have the same have the same features, right? Yeah. Yeah, maybe we may discuss this later, and yeah, it's a bit long. Yeah. And yes, let's go back to the documentation about the best practice and the guidance for secure containers. Yeah. And actually, I like to say you use the secure containers that depends on your applications, and you need to make some decisions for that. And the first thing is about what do you really want to achieve. That means you want better security or some other isolations, performance isolation or something, and you need know the overhead for them, and because right now there will be will consume some performance and memory, and also for our organization, we use the Kata containers for some for different applications, and for us, we think that that increased the security level and also the performance isolation. So that's worthy to introduce them. And for the but I think for the telco network functions, maybe the network latency is the most important part, and you need to consider, or maybe need to in some tests to ensure is that really what you want. And also, but actually for RAC, that's still some. I think that's the same issues about the performance part, and also for the virtualization part, there have already been some optimizations for NFV technology. So I think that may workable, but personally, I'm not working for the telco part, and yeah, I think that will be some difference between the different industries, and but so far for some generally I think the secure containers could be especially for Kata could be used for most of the case that we can use the RAC for that. Is there anyone who want to talk about the best practice and guidance? I noticed the Rama Prasad have mentioned that the APP armor, right? Yes, I missed the app armor for the security of the containers, the ways for them, and yes, that's also part of also technology to enhance the application security. Yeah. However, it's still the shared kernel solutions. And there's still some restrictions for the method. And yeah, do you have any suggestions for that? Implementation takes memory. Yeah. And yeah, for the if there's no other comments, the last one will be talk about the service mesh. Yes, I think the service mesh will be part of the security technologies, and that's there are something about the end-to-end encryption by maybe introduced by the service mesh, and also for the identity part and for policy. So the service mesh could be used to improve the infrastructure's security level. Yeah, I agree with that. And yeah. multi-security? No, anyone?
Yeah, this is on the Ingress side. So I've seen before some really large customers with large Kubernetes implementations using ModSec on the Ingress side as well, almost as a way to get around using network policies. And I'm wondering if anyone else had kind of explored that on the security side. Maybe not, but it seems to be a kind of, I see some traction on this a bit.
Yeah. Yeah. Enable security. So it's work like a egress proxy, right?
Yeah.
Yeah, I think that's also might be part of the end-to-end security, because the security is a pretty large topic here, and for the network part, the end-to-end security is right. The network security and the security database must be one of the chain of the end-to-end security. And yeah, go back to the security policies. Yeah, there's someone mentioned the OpenShift security context constraints, and also I mentioned Lifebook. Yes, looks like there have already been some other flavors to implement the security policies for applications. And is there any other topics we still want to talk about? APP Armor? Someone else? Looks like we have discussed many different points about the security and isolation of containers. I think firstly, I think there are many ways to increase the security of containers that we have discussed, and also many people are really interested in the overhead of the security method, and also the best practice of the secure containers are interested to add to most of the attendees, and let's talk about the logging and the monitoring. Do you mean the logging for the security itself, and all how the security methods affect the logging and monitoring? actually, I think for our team, for the Kata containers project, the 2000, one of the most important goals of the version 2.0 is to increase the observability and operability of Kata containers. And we have injected many metrics and others to increase the observability, and also we want to help we have the better logging for them. And and is there anyone want to have more input about the logging and monitoring? Yeah, some of my points on the monitoring, and yes, and I think that if we want to increase the security, that always makes the monitoring and the debugging become harder for the users. So we have to work more on the observability and debuggability for the applications, so that people can have the users can have the same or maybe better tools for their applications, and that's really important for the developers.
Okay, well, I think this is a great stopping point for this. Thank you so much, Shu, for that summary. We have a couple of minutes left, so I'm wondering, Gergely, is there anything that we should circle back to? I know that there were a lot of follow-up and action items from that first discussion, so is there anything that you'd like to use the remainder of this time for, just to circle back on that, since we're kind of jumping into the wrap-up now?
Nothing from the top of my head, but of course, if there is a willingness from the audience to discuss more the topics, then we can pick another topic from the list.
Okay. Wes also just dropped that wrap-up Etherpad in the chat if anybody else wants to jump in there.
Yeah.
Why don't we go ahead and summarize the follow-up groups from what we listed there, because I know there were a bunch, so maybe it would help to just recover those.
Yeah.
Okay, so from the first discussion on follow-up, we will start an email discussion about how to agree in a networking API for Kubernetes. And to be honest, I already sent out the first email, but if somebody is interested in joining the discussion, then if you add your email address now, I can forward the mail to you, and that should happen in line 98 of the original Etherpad. And there is another agreement that we will continue the discussion in mail about how to agree on the best practices about workload separation in Kubernetes. And if you are interested about that, please add your email address to line 172. in the original Etherpad. Let me just add those line numbers to this.
It looks like, is Taylor Carpenter still on? Looks like they dropped an invitation to join the collaborative workload requirements meeting at 9 a.m. I guess tomorrow, unless that was today. I'm not sure, but if you'd like to speak a little bit more about that, feel free. There's a link to
Hey, this is Taylor. I'm still here. Can you hear me?
Yeah, hi.
Hey, yeah, that's actually today. So
Okay.
It's a, this is related to some topics earlier on the where are we gathering requirements and stuff. This specific one is focused on the workloads, so relevant now. There's a lot of different efforts on trying to implement, test, gather requirements, and several of the groups were mentioning this, including Elephant's OVP initiative for badging, looking at their second version of badging. And we decided to get together and try to put those requirements together, and then also do a focus on the requirements as well as the test tracing, the testability. So this could be different test suites and different efforts. And we started a weekly working session. That's the 9 a.m. Pacific. And there's a spreadsheet where we're gathering the information. The slide deck kind of goes over how that works. And the idea is to take all the requirements and then provide them to whoever wants them. So this is kind of like an upstream effort for requirements. And then at the same time, some folks have mentioned that they're keeping in mind the actual tests, so you may be working the other direction.
Got it. Well, thanks for dropping that in there. So that's in about 30 minutes here.
That's right.
Mm-hmm. Okay, well, is there anything else that, Gerge, you would like to cover from that session? Looks like we have most of the follow-ups here.
Yes, these are the two things which have a concrete follow-up.
Okay, great. Would you like to give a quick summary of all of the different topics you covered in that session, just for folks that might have missed it?
Yeah, sure. So we covered, so we started from like the requirements side. So the first topic was to discuss what kind of requirements telecom workloads have, which are, let's say, justifying the usage of different extensions to Kubernetes. And we discussed two of these. First one was the classical multiple pod interfaces, and the second one was the network API. And about the network API, we agreed that we will need to continue the discussion, and this is where we will have the first follow-up action. Then we discussed about workload separation best practices. for telecom workloads. So the basic problem is that what kind of methods are the most optimal to use to separate different telecom workloads from each other in Kubernetes. There are different techniques to do that. So we can use separate namespaces, or we can use separate clusters, or if we would like to discuss on different domains, it's also possible to use network policies and so on and so on. So there are lots of ways to do separation, and of course we have the separation within a host using different runtimes which are using virtualization technology. And we agreed that we need a place to write down the best practices, and we will continue the discussion an email. So that's the second follow-up activity what we will have. And of course, I believe that this really depends on what kind of trust is there between the different workloads. So this, I think that we will have separate best practices for workloads which can trust each other and between workloads which do not trust each other. So that was the second big topic what we discussed, and the third topic what we, let's say, have discussed, because we had only like I don't know, some minutes to cover that, was the network acceleration topic in Kubernetes. So here I think the main conclusion, at least for me, was that the real question is how can we do the job with the least cost? And it doesn't really matter if we use some acceleration technology or we use community hardware. So it always depends on the use case what we would like to cover and the technologies we use, if it's worth to do hardware acceleration. At least that was my learning on the topic. And unfortunately, that was all what we could discuss in the first session.
Gotcha. Well, it's a good thing that OpenDev is based on follow-up. So I think some of those action items are really beneficial going forward. So with that, thank you. And I noticed that I think John and Christoph are still on. Would either of you like to mention any follow-ups from the sessions yesterday that we'd like to note here?
Not from my side.
That's a good question. Have we got, I'm trying to think of the follow-ups we had on the Etherpad yesterday. We definitely spoke about following up about accelerators and the various things in the scientific SIG. So that's how you pass through into the VM or use them in the bare metal, and how that interplays with Kubernetes.
Okay, great. And we can drop a link to the scientific SIG and how to get plugged in there as well. Maybe somebody from OSF can do that. Well, great. Thank you, everybody. We'll call that a wrap. Don't forget to leave us any of your feedback from the event, general feedback, what your hopes for the future for this event would be. So we have that Etherpad at the top of this doc. So feel free to jump in there and let us know your thoughts. And don't forget that we also have another event coming up in October, the 19th through the 23rd, and that'll be our Open Infrastructure Summit, and that'll be virtual this year. The CFP is already closed, but if there's anything that you definitely want to make sure that we talk about at the summit, please email us at summit@openstack.org, and we hope to see you there. The event is free, thanks to our amazing sponsors. So make sure to register, and we'll see you there. Thanks, everybody.
Thank you. Bye-bye.
Thank you.
Thank you. Bye-bye.
Yeah, thanks. Bye.